All right, today we are learning how to solve quadratic equations, and there's actually like 5 different methods. We're going to do 3 of them today, 3 full methods today. So solving quadratic equations by graphing is what we're going to start with. A quadratic equation, we've already talked about ax squared plus bx plus c equals 0. A, b, and c, those are all numbers. And then here's some new vocabulary. A root of an equation is the solution. It's the solution. So when I ask for the root, I'm asking for you to find what x equals. You're solving the equation for x. And then there's some other vocabulary that means do the same thing, but there's like 3 different ways you're going to see it phrased. You might see the solution of an equation. You might see the root of the polynomial. And you might see the 0 of the function. All of those mean the same thing. They mean solve for x. Every single one of them means solve for x. Graphically, because we're going to be solving these by graphing, graphically, the root of a polynomial, the 0 of a function, the solution of the equation, mean the x-intercepts. When y equals 0. So we're going to be finding the x-intercepts, or when y equals 0. Graphically, we could have a picture that looks similar to this, and how many x-intercepts are there going to be in this picture? 2. There's 2, but what other options do we have? No intercepts. We could have none. The parabola could be above the graph, or below the graph and opening down. And then this would be none. And then how about 1? How would that look for 1?
The vertex is on the x-axis.
Right. If the vertex was on the x-axis, there would be 1 time that the parabola crossed the x-axis. We just touch it and go back up, or touch it and go back down. So there are 3 methods we're going to learn today. The first one we're going to do by graphing, and then later we'll do square roots and by factoring. So to do the first one by graphing, we're actually going to utilize our graphing calculators. On your graphing calculator. I'm going to do the graphing calculator stuff underneath my camera. You guys pull out your graphing calculator. And we're going to go to y equals, remember all the graphing buttons are at the very top, those 5 buttons at the top. Go to y equals, make sure there is nothing in there. And if you look at the plot, 1, plot 2, plot 3, we had been using those earlier, they should not be darkened. So if they are, then you need to go up and hit enter to turn them off. So up here, make sure those are not darkened. And go ahead and type in your equation. X squared minus x minus 6. That's right. Now your window might be off, because we've been doing this for stats recently. So your window might be off. Let's fix our window together. So to fix our window, you can either go to window, but let's do something that takes 2 buttons to fix your window, okay? Go to zoom, and then choose number 6. You can just hit the 6 button. Zoom standard, zoom 6. And then it will make a nice 10 by 10 window. 10 by 10 by 10 by 10. And we have our graph. So we are going to graph this on the paper. So how are we going to possibly graph this picture on our paper?
Cry.
Huh?
cry, let the tears fall into the tears.
I'm not sure.
How are we gonna graph this on the paper?
You look at this, trace it.
How are we gonna look at the point?
10 by 10.
Okay, so we've got a few things out here. There's a few things we're gonna do. I'm gonna show you how to find the x-intercepts. However, you'll probably look and see where those x-intercepts are. But I'm gonna show you how to find them just in case they're not so obvious. So I want everybody to go through these steps, so when you have a harder one, you know what to do. To find the x-intercepts, we're gonna go to second, ooh, this would be a good thing to write down. Second trace.
Second one.
Trace. Second trace. That's the calculate button. And then once you go to second trace, you see this menu of options. One of these has to do with x-intercepts. It is 0. Because that's new vocabulary that we just had up on the board. 0 is what you're going to choose. So you're going to choose number 2, 0. That would be another thing you write down is which one you choose. Then it says left bound. And I need for you to look up here for a second so you understand left bound. So my x-intercept is approximately right there where my little bug is. To get the left bound, you need to hit your left arrow so that you are to the left of that x-intercept. And as soon as you're to the left of it, hit enter. And if you have the newer calculators, you will see a line come up. But if any calculators, you should see this little arrow. And then it says the right bound. So wherever that x-intercept is, I'm now going to hit my right arrow over. I'll be right there, man. And then hit enter. And now it should pull up a window that the calculator is looking in between to find your x-intercepts.
Oh, wow.
Yeah.
You don't have the one. It's the newer ones have the one. But you do have an arrow. It's just kind of turns. Okay. Wait. I didn't give you less directions.
Mine's like,
I did my white.
yeah.
mine's really wide.
So you were not listening.
No, I did it before because I was in the middle of the.
Right, but we're not doing the Minimax.
Well, I didn't. I just did it.
Okay, so second trace, 0. No, she didn't do it. And then choose the 0. And then again, you're going to the left and the right of the x-intercept. When you get as far as I've gotten and it says guess, that's where you go close to the x-intercept and you hit enter. And then it should tell you at the bottom, this is the 0. -2, 0. So what I'm going to do now is I'm going to go, you guys, I will come around and help you. I'm going to pause it before I do that. But I'm going to go to the graph, and I'm going to plot -2, 0 on my paper and my notes. Okay, now I'm going to come and I'm going to pause it. I'm going to come around and help you if you need help. If you do not need help, try to find the other x-intercept. All right, to find the second x-intercept, which is all the way over there, I'm going to again do second trace and again do 0. And this time I have to be to the left of the other one. And then to the right of this other one. So you can see that I've formed a window where the calculator is going to look in between. So I'm going to use my arrow and say guess, and it tells me 3, 0 is my other x-intercept. So I'm going to go to the graph, and I'm going to graph 3, 0. So let's go find our vertex. To find the vertex, same thing, second trace, and it doesn't give you an option for vertex. So you have to know if we are finding a minimum or a maximum. And it would be a minimum, right, because the graph has a low point. It opens up. So we're going to choose number 3, minimum. And the vertex is all the way at the bottom, so that's the point that I'm doing the left bound and right bound for. This bottom point, I'm going to go to the left of it and hit enter, and go to the right and hit enter, and then guess, enter, Now, it's going to give you probably a weird decimal, and it might be different than mine.
I have like point.
Did you get exactly 0.5 or did you get 0.5000? Right. So the answer really, I promise you, if we did negative b over 2a, if we worked it out by hand, the answer would be 0.5, negative 6.25. But for some reason, the calculator can't be 100% accurate because of the pixels, or I don't even know what it is, but if you get a number that looks like this, it is 0.5.
But why does the graphing calculator see it like that?
I don't know, and you know what? Someday I'll look it up, but I haven't. So the vertex is really at 0.5, negative 6.25. And so we'll graph that. Half, and then down 6.25. What's this dash thing I'm drawing?
Symmetry.
Good, axis of symmetry. 3 points really isn't the best amount to have your graph. You would need at least 5 points, right? So the last thing I'm going to show you, which we've looked at before, you can go to your table to find more ordered pairs. So we do second graph, and there is a table of all kinds of ordered pairs for you. So now I'm going to pick the ordered pairs, I don't know, -1, -4.
Mine goes to
Okay, we have played with the table before. Let's set it back up for you. Go to table set, which is second window. And then you can tell your table to start at whatever number you want it to start at. You can tell your table to count by whatever you want it to count by. So I have mine starting at -3 and counting by 1s. But you can have it start at whatever you want it to start at. Count by whatever you want it to count by. Second graph. So from that, I'm going to graph those other couple ordered pairs that I had found here, -1, -4, what's another one? Now I have plenty of ordered pairs to see my graph. Now, the question was really just asking what the x-intercepts are. What's the solution? What are the zeros? Solve each equation. That's just the x-intercepts. And how many are there? There's 2. So when we solve an equation and you have more than one answer, you have 2 or more answers, you have to somehow show that each answer is a possible answer. I've got 2 ways you can show that. Your first way would be set notation, which you start with a squiggly bracket. You write both answers in numerical order, so -2, 3, squiggly bracket. That's one way that you could show your solutions. The other way, if you don't like set notation and you like writing more, the other way that you could show the same thing would be to write x equals -2 or x equals 3. But you have to have the word or in there. You have to have the x equals every time. So those are the 2 acceptable ways that you could write your answer. I prefer less writing, so I always do set notation. All right. So I'm going to pause this, and you guys are actually, before I pause it, we're going to work through B. We're going to do it on the calculators, but before we do that, how is equation B different than equation A? Yeah, you have to have all the stuff on one side to be able to type it in your calculator. So how are we going to move 4x over? Okay, we're going to subtract 4x. And if I'm subtracting 4x, you cannot subtract an x from an x squared. They're not like terms. So we're just going to write this as -2x squared minus 4x minus 2 equals 0. And this would be like where y is.
Well, could you also just take the -2x and -2 to the other side and have everything positive?
Yes, you can also do that. Gino just suggested, can I just add 2x squared and add 2 to both sides so everything's positive? Yes, that would be another way of writing it. Either way, you're going to get the same answer, the same solution, the same x-intercepts. I'm going to pause it so that you can graph that and find your solutions. Okay, so some of you may have gotten this negative 4.5e, negative 12. Some of you may have gotten it, or you might get it in the future. So this e, that's scientific notation, that's like 10 to the negative 12. And basically that means 0. It's just our calculator is a tiny bit off. Your maximum should be negative 1, comma 0. That's what the real maximum is. If we had done it by hand, we would have gotten that exact negative 1, comma 0. We're using the calculator, it's off just a tiny bit. So this means 0, if you see the E. So here's another thing that is kind of cool about your graphing calculator. When you go to do second trace and say we're going to do 0, we're going to do the x-intercept, and it says left bound, if I am feeling extra lazy and I do not want to arrow, 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 arrow over, I can just look here and say, well, it's definitely not at like negative 3. It's somewhere, like negative 3 would be to the left. You can actually type in negative 3 instead of arrowing for your left bound. So what would be a good right bound that is definitely not that? You go all the way to 4, sure, 0, 1, something like that. I might choose 1.
You can go to 82 if you wanted.
Yeah, I don't know. It might give you an error if it's not on the screen, but we would just have to try that and see. And then for guess, you can also put in a guess if you want, and I'm going to guess wrong, okay? So I'll show you what happens if I guess wrong, but you can put in a guess. So I'm going to guess 0. It's not at 0, but I'm going to guess it. But it still tells me the right answer. Negative 1, 0.
Negative 1.5.
Well, you know, something's off a little bit with that. Do you have the solutions written there? Exactly. So then we have our vertex graphed, which is also our x-intercept. We've got some other ordered pairs graphed. And we have our parabola. The question is, it's just to solve the equations. The question is, what does x equal? So we write x equals negative 1. Now, how many solutions are there? How many x equals are there? Just 1. So you don't necessarily have to have them in the fancy bracket because there's just 1. It doesn't hurt to have the fancy bracket because then you remember to do it. But just having one answer, you can just leave it. It's when you have more than one that you have to have like the set notation. Please put your phone away or it will be mine. Thank you. All right, we are moving on. We are now learning how to solve a different way. This is now solving by using square roots. You will see at the top it says, remember to rationalize the denominator. That would be something that you probably did in geometry, that we're reviewing. They definitely did in Algebra 1. We're reviewing it. Okay, to solve these by square roots, we have to get whatever is squared by itself. So we're just solving an equation. So we get x squared by itself. So what would I get rid of first? I would add 31 first. You're doing the opposite of order of operations. You get rid of the thing that's furthest away from the x squared. We have 4x squared equals 80. Then we do what?
Square root.
Nope. Divide by 4. And we get x squared equals 20. So we got all the way, so we have like x squared by itself. Now we cancel out the x squared by doing the square root. And I know we've talked about this so far this year. If you put the square root in yourself, you have to have two answers. You have to have a plus and a minus. Because x squared means two answers. So a plus and a minus. So my next step looks like this. X equals plus minus square root 20. Do not type in square root 20 in your calculator. That is not a very accurate answer. We're going to give the most exact answer. And to do that, you're going to simplify your radicals. And I know, well, I don't know, but I know if you had me last year, I know if you had Miss V last year, I know a lot of you have done this. You did it last year a lot. You have to break down 20 so that the first number is a perfect square. What perfect square divides into 20? 4 goes in 5 times. What's a perfect square mean? It means that I can take the square root of it.
2.
So I now have x equals plus minus 2
Square root 5.
square root 5. And how many answers is that?
2.
That's 2 answers. So I can either write it as plus minus square root 5 in squiggly brackets, or I can write it as x equals 2 square root 5, or x equals negative 2 square root 5. Taking no shortcuts, you have the word or in between, you have x's for each one of them. I don't want to write it that way. Just giving you options. All right, that was first example. Let's do the next example. What are we going to do first? 3x squared plus 9. Minus 9. Now what do we do? Divide by 3. Okay, I have x squared equals negative 3. I have x squared, so what can I do at this point? Square root. But if I square root, I have to include both answers, plus and minus. So I have plus minus square root negative 3. What can I do? Why not?
Please, prime number.
Oh, you guys are missing something big time.
Have the negative.
Oh, no.
You can't have a negative like radical. You can't do that. So there is no real solution to this because we're trying to square root a negative number. If you try to square root 3 on your or negative 3 on your calculator,
Just be like,
yeah, it will. It'll say error.
that's not correct.
So we have no real solution. There's no real solution. How would that look on a graph? How can we have no real solution on a graph? What are the solutions?
X-intercept.
The x-intercepts. So how could we have no real x-intercepts on the graph?
Are you recording?
Yeah.
It doesn't look like you are. So.
Thanks for checking. So this would be a graph, and if you look right here, the A value is positive, so this would be a graph that opens up. This would be a graph that looks something like that, where it opens up, but it's above the graph. It's like, I don't know, how many above the graph? What do you think? How many above the graph is it? 9 above the graph. Right. So that's why we don't have any real solutions. Don't worry, our next section you'll learn what to do when we don't have real solutions. They're imaginary. Well, we'll save that for next class. All right, last one of these. What should we do first? Oh, wait. There isn't an x squared for this one. What? No, don't do that. There isn't an x squared. There isn't an x squared. There is an x plus 3 squared. So we're trying to get x plus 3 squared by itself. So how do I get rid of this stuff other than the x plus 3? Okay, we're going to multiply by what are you saying? 5 over 2. You multiply by the reciprocal to cancel out a fraction. So that cancels the 5s. That cancels the 2s on that side. So on the left-hand side, we have x plus 3 squared. On the right-hand side, I'm multiplying the number 5 by 5 over 2. 5 is the same thing as 5 over 1. So I multiply straight across, and I get 25 over 2. And I'm going to leave it as a fraction because of our next step. Once you've gotten here, do you see we have x plus 3 squared? So squared's the outside thing. How do I get rid of squared? But if I square root, what else? Yes, positive, negative. You have to have the plus minus in there. So now I have x plus 3 equals plus minus. Okay, when I square root a fraction, I'm going to immediately go to this next step. Square root of 25 divided by square root of 2. If you're squaring a fraction, there's a quotient rule that says you can square root the top and the bottom separately. So that's going to help us move on. Right, and the square root of 25 simplifies? Okay, well, we'll go ahead and do that. X plus 3 equals plus minus 5 over square root 2. Now let's think back to Algebra 1 and geometry. What am I not allowed to have right there? Can't have a radical in the denominator. No rat in the den. Multiply by what? Okay, you have to multiply by a value of 1, so it doesn't change the value of this. It just changes the appearance. So we're multiplying by the same number on top and bottom. That number that we chose to multiply by is the radical that's on the bottom.
And since you basically multiply by one, you don't have to do it to both sides.
Right. I mean, I can multiply this other side by 1, but it doesn't change anything. Okay. So now I have plus minus. When I multiply fractions, I go straight across. So I got 5 square root of 2 on top. Those you cannot multiply together because one's a radical and one is not. On the bottom, they're both radicals, so I can multiply them together. Square root of 2 times square root of 2 is the square root of 4, which is just 2. I cannot cancel this 2 and this 2 because one of them is a square root and the other is a regular. So you cannot cancel those or you would... Bunny. Don't do that. Don't cancel those. There is one last step to solve the 3. We're going to subtract 3. And order-wise, we always write the number that is by itself without the radical. We always write that number first. So I'm going to write x equals, then I'm going to write that negative 3 first. Then I'll do plus minus 5 radical 2 over 2. That's more than one answer. So I'm going to put it in fancy brackets. And then I'm going to show you the other way you could write the answer if you wanted to, but I wouldn't write it this other way. You could also write x equals negative 3 plus square root of 5 square root of 2 over 2. Nope, messed that up. Sorry. Or x equals negative 3 minus 5 square root of 2 over 2. So that would be the other way of writing the answer, but I would prefer this method with the squiggly brackets. Almost done. Almost done. I know. A lot of stuff. Okay. Okay, this last section is to solve by factoring. So we can go really fast through this because you already went over how to factor. Now we're going to solve by factoring. It says at the top, remember to set the equation equal to 0 before factoring. That's very important. It has to say equals 0 first. So solve x squared minus 4x equals 45 by factoring. Does that say equals 0? No. So how do we make it equal 0? So we have x squared minus 4x minus 45 equals 0. We subtracted 45 from both sides. That's not a like term with anything else. We just put it on the end. Now this is to solve by factoring, so what should we do next?
Probably
Factor. So then, what are our steps for factoring? First step is
Greatest common factor.
greatest common factor. Is there a greatest common factor?
No.
So then next, how many terms?
There's 3.
3 terms, so that is the guess and check method. So we're gonna have an x and an x. What are our signs?
Negative, so it's,
We're gonna have one of each, because this sign is negative, that tells us one of each. And then what makes 45 that could possibly give us a negative 4? Negative 9, positive 5. Excellent, so we have it factored. Now, our next step is set each factor equal to 0.
It's the same thing as the x-intercept.
Because what are we finding right now?
X-intercepts.
We're finding x-intercepts. So it is the exact same thing that we've already done. That should be easy. So you set each factor equal to 0, subtract the 5, add the 9, and we have 2 answers. So my answers are negative 5 or positive 9. One more example to do. Same kind though. Yes?
Does it matter which one you write first?
We do it in numerical order. So I put the negative number first. All right, last one. Find the zeros of f of x equals 2x squared minus 11x plus 12. What does zeros mean?
Solutions.
Solutions, roots, solve it. But it has to say equals 0. Well, we're not going to just put 0. So the x-intercepts are when y is 0. And remember, a different way of writing y is f of x. So I'm just going to take out f of x, and I'm going to make it 0. So now I'm finding when f of x, or y, is 0. And we're doing this method as factoring. So is there a greatest common factor? No.
no.
So then our next step would be guess and check. I know that this is 2x and x. I know my signs have to be what? Both negative, right, because the plus sign says same sign here. I have to get negative 11. My choices for 12 is like 1 and 12, 2 and 6, 3 and 4. So I'm thinking negative 11. Whatever I put in this spot has to multiply by 2. So I'm looking at multiplying one of these numbers by 2 and using the other one to create 11. So what am I going to multiply by 2?
4.
Right, 2 times 4, and then another 3 on top of that is going to give us negative 11. So then we have it factored. Now what do we do with each factor? Set each factor equal to 0. And solve for each factor. So the first one, 2x minus 3 equals 0. I'm going to add 3. 2x equals 3. Then divide by 2. So I get 3 halves. And yeah, I usually leave it as a fraction. Over here, I'm going to add 4. And then that one's solved. So my 2 answers, x equals 3 halves, or x equals 4. What number would I put first? Okay. Excellent. Feeling good. I know factoring is the easy part, right? your assignment is
Online.
in Big Ideas. You do need to do some like factoring and square rooting on paper. So make sure you have paper available. If you look at your notes, the last page is blank. There's a place you can do it. Go ahead and grab your computer. Maybe grab somebody next to you.